Welcome back. Today we're going to go a little further with our ramp or no ramp lab that we did in class. In class we used a shoe or a block of wood, a spring scale, we used our meter sticks, and we measured the amount of work necessary to lift your shoe straight up off the ground or the block of wood, and to lift that block or your shoe up an inclined plane or a ramp. And from that lab, we saw that the amount of force necessary to lift the shoe straight up off the ground was greater than the amount of force necessary to use the inclined plane to get that shoe or block up to the same height. Okay. So what I also wanted to show you was the length of the ramp, because we had a problem with our ramps in class. If you recall, the lab paper asked us to use a ramp a distance of 51 or 50 centimeters, 0.5 meters, but our ramps weren't quite that long, so we had to adjust. And so with this lab, what we're going to see is we're going to have no ramp, and then I'm going to do trial number 2, which will be a short ramp, and then trial number 3, which is a longer ramp. Okay, so just like in class, we're going to lift the wooden block straight from the ground at 0 to half a meter or 50 centimeters. And then trial number 2, we're going to use a short ramp, which is 0.8 meters or 80 centimeters. And then we're going to use in trial 3 the longer ramp, which is 1.22 meters, which is 122 centimeters. Okay? So in trial 1, trial 2, and trial 3, you're going to need to record your information in your lab journal, just like we did I set you up in class. And then together we'll calculate the work. And we're going to see as the force changes, the distance changes, how the work is affected. Okay. So trial, make sure you have your journal handy. Write these numbers down. Trial number 1 is going to be with no ramp. Okay, and we're going to go, our distance is going to be 0.5 meters. So write that down, and I will tell you the amount of force that's necessary. Okay, same blocks that we used in class, the brown spring scale that we used in class. And just like in class, we're going to start from 0, and I'll tell you how many newtons of force we're using as we get up to 0.5 meters, which is marked here by the bottom of my pink tape. So when we lift up to 0.5 meters, right at the bottom of my pink tape, make sure I'm there, we're looking at 3 newtons of force. So write that down for trial number 1. We're going to calculate the work necessary. We're going to multiply 3 newtons times 0.5 meters. Write that down, and I'm going to get my second ramp going. The second ramp for trial number 2, the distance is going to be 0.8 meters. I'm going to grab my rock here and block up my ramp so it doesn't slide off while we're doing our trial. Make sure we're all flush and straight. So our distance is going to be 0.8 meters or 80 centimeters. So we're increasing our distance. We're going to see what happens to our force needed to get the block up to the same height over a greater distance. Okay, so checking my math real quick, make sure I did it correctly. Okay, so we start at 0. We're going to lift the block up the ramp, 0.8 meters, and to get up that high, we used about 2 newtons of force to do that. So for your force, write down 2 newtons in trial number 2. I'm going to stick this over to the side. Alright, so here is ramp number 3. So under trial number 3, write down 1.22 meters. 1.22 meters. Let me set up my rock and set up my ramp just like we would in class. Okay, we're going to go the same height off the ground. It's going to be the same distance from the ground up, but we're increasing that over from 0.5 meters to 1.22 meters. So let's see what happens to the force needed to get that same block up a greater distance. All right. So for trial number 3, Same blocks, same, keeping those things constant, same spring scale. We are at about 1.4 newtons of force. So write that down in your journal under your trial number 3 for your amount of force necessary to travel up 1.22 meters. Our force is 1.4 newtons. When we get back together in class, we'll do the math and we'll see what happens to the amount of work as the force changed up and down and the distance changed.